Today's lesson is called The Computation of the Slope of a Non-Vertical Line, Day 1. So a reminder from our previous lesson, we find the slope, which is the measure of the steepness of a line, using the ratio rise over run. In other words, the change in the y values over the change in the x values. But mainly, we use this rise over run when we're dealing with a graph and we can count the blocks. So what I'd like you to do for this opening exercise is to complete this on your own. It says, using what you learned in the last lesson, determine the slope of each line given on the graphs below. So you're going to look at the graph on the left and also the graph on the right. Use the points that have already been plotted for you to find the slope of each of these graphs. You're going to pause the video, and when you're done answering these two questions, resume the video to go over your answers. All right, now that you had a chance to try on your own, let's take a look together. For the graph on the left, if I'm reading from left to right, I would have to go up 1 block and to the right 8 blocks to get to my next point. Up 1 would be positive 1, right 8 would be positive 8, which makes my slope 1/8. In the graph on the right, reading it from left to right, it doesn't matter which 2 points you use here, but pick from 2 that were plotted. We are going to go down 3 and to the right 5. So down 3 would be -3, right 5 would be +5. So that is -3/5 for a slope. Now moving forward together, sometimes you may have to reduce the fraction that you found for the slope of a line. So we're going to do this slope together. We're going to go again left to right. And if I'm looking at this, I see that I'm going to have to go up 1, 2, 3, 4, 5, 6 boxes because we are going by ones on the scale. So each block is worth 1. And then I still would have to go to the right 3 blocks. So my slope is going up 6, then right 3. So that is up 6, a +6, right 3, a +3. But you can see I wouldn't leave this as 6/3. This can get reduced to 2/1 or 2. So I can write my slope as 2. In the one on the right, again going from left to right, I would have to go down 2 blocks because again we're going by ones. And then I'd have to go to the right 4 blocks. So when I find the slope here, m is equal to down 2 over right 4. Down 2 is going to be a -2. Right 4 is going to be a +4. So this again turns into a fraction that we can reduce. -2/4 is the same as -1/2. So my slope would be -1/2. So just wanting to demonstrate slope again for you with me doing it along with you, and also introduce you to ones where if the points are a bit further apart or you choose points that are further apart, you are going to have to reduce either the fraction or the fraction that turns into a whole number for your final answer. And next I want to talk about something that I get a lot of questions about. Everyone gets nervous that they're reading the graph incorrectly. And the good news for when you're working with a graph and you're finding slope is that you can find the slope whether you go from left to right or right to left. So I want to demonstrate that with you looking at example 1. So here I also want to demonstrate picking your own points. On the graphs that I've been giving you recently, I have plotted points for you. I'm going to stop doing that now. You have to find 2 points that you want to use to find the slope of the graph. In this example, we'll do this together, okay? So the first point I picked was this point right here, which is 0, 4. And then the next point I picked was 3, -1. Notice I picked 2 nice points that are exactly located at where 2 grid lines intersect. So now we're going to read it left to right like we always have been doing. So I would have to go down 5. So m equals down 5 over, I'd have to go to the right 3 units. So right 3. This is a 5. So that tells me down 5 is negative 5. Right 3 is positive 3. So my slope is negative 5/3. Now, I want to show you, which is new for the first time, that it's okay if you read the graph from right to left. So that means we would start at this point in green to this point. So I'm going to have to go up 5 units and left 3 units. So M equals up 5 over left 3. So up 5 would be a positive 5. Right 3 would be a negative 3. But that's still overall negative 5/3 for our slope. Did we get the same thing whether we went from left to right or right to left? Yes. We can write down officially that our slope is negative 5/3, and it doesn't matter which direction I read the graph from. All right, so we're going to go on to example 2. I'm going to pick 2 points with you again because this is an example. So 0, negative 1. You're going to go up 2 and to the right 1 to get to the next point I picked at 1, 1. So for my slope, I have up 2. On the bottom, I have right 1. Up 2 would be a positive 2. Right 1 would be a positive 1. So this is 2. I have a slope of 2 when I read it from left to right. Let's read it from right to left instead. So we're going to start at 1, 1. I'd have to go down 2 and to the left 1. So M equals down 2, left 1. So down 2 would be negative 2. Left 1 would be negative 1. What is a negative divided by a negative, though? It's a positive. So negative 2 divided by negative 1 is 2. And yet again, my slope is 2. Did we get the same thing whether we went left to right or right to left? Yes, we did. So M equals 2. So again, let me recap. You reviewed what you had done the lesson before. I talked to you about the fact that if the points are further spread out, you might have to reduce the fraction. And now we know you don't have to stress about whether to go from left to right or right to left. You get the same answer either way. So the final thing I want to address with slope, and I get this question a lot too, is can we find the slope between any 2 points on a line? Students get very nervous that they're not picking the right points. So we're going to investigate this as the conclusion to our lesson. So if you're watching this alone, you're going to pause the video and pick 2 points and follow the directions just as partner 1. If you are listening to this in class with a substitute teacher, just make sure you pick different points than the partner sitting next to you, and the substitute teacher will prompt you through this activity. We are going to pick 2 solutions, which are points, off of this line. And you can see I've already labeled points for you, and I marked them with a letter A through F. You have to have different points than your partner. So for example, if I'm partner 1 and I pick points C and D, then my partner 2, cannot pick C and D. Maybe they'll do E and F. Okay? You are going to find the slope between your 2 points, and then you're going to compare your slope either with me in the video or with your partner. And then we're going to make a conclusion statement about can we find the slope between any 2 points on the line. So at this time, you're going to pause the video and complete the investigation activity, and then resume the video to go over the answers and discuss the results. I completed both partner 1 and partner 2 just to show you an example of what I mean. For my partner 1 values, I picked letter A and letter B. So that was -5, 8 for a coordinate and -1, 4. And I went up to the graph and using rise over run, I decided to go from left to right like I usually do. I got down 4 to the right 4, which turns into -4 over 4 or -1. Then for partner 2, I decided to pick point D and E. So that's 5, -2, and then 7, -4. And I went to the graph and used rise over run to see that I had to go down 2 to the right 2. So down 2 would be -2, right 2 would be +2, which gives me a slope of -1. So this is just an example, but as you can see, I get the slope no matter what 2 points I pick to be the same thing. So under our conclusion, can we find the slope between any 2 points on a line? Yes. The slope is the same between any 2 points on a line, and if we kept doing this, it would continue to happen. So that concludes our lesson on the computation of slope of a non-vertical line, day 1.